Hi, this is Mike Ward. Very quickly, I want to take you through some principles that relate to the time value of money. So to start with, I want to go to Excel and start with a very simple little problem. Now, we all know that if you have, for example, 1,000 Rand in the bank and interest rates are 10%, you know that if you left that money in the bank next year, this is going to increase. And we would do this by saying it's going to be equal to what it was times 1 plus, the 1 just means start with 1,000, and we'd want to increase this by 10%. And I'm just locking that cell down in Excel with F4. So you can do this in your head, of course. You're going to expect this answer to be 1,100. Now, if we were to leave it there for another year, then it's going to grow. And it's going to grow by more than 100. Let me show you. You can see it's actually grown by 1,000. Well, it's become 1,210. And the 10 is the interest on the interest over here. We call this compounding. Now, we could write a formula for this because what I'm going to show you just now is that when we talk about the time value of money, we generally speaking are doing the very opposite to what we're doing here. Instead of adding money like this, we start with a number over here, which we're going to hopefully get in 5 years' time, and we need to bring it back to the present. So if we were to write a formula for what we're doing here mathematically, you can see I've done it over here. We would say the future value. So let's say we left our money in the bank without adding any more, but just accruing interest year by year by year for 5 years. We would say the future value, FV, is equal to the present value, this the 1,000 here, times 1 plus K. That's what we were doing just now, but we would need to put it to the power of 5. Now, if we're going to reverse this, and here I'm just doing a little bit of algebra, if we knew what the answer was in year 5 and we wanted to bring it back to the present, which is what we really need to be able to do, we would have to just rearrange this formula. And I'm just showing you, here it is. The present value is going to be equal to the future value. So we would take this number here and we would divide this by 1 plus K to the power of N. So that's in essence what we're actually doing. Now, let's kind of leave it at that. And let's imagine that you had a phone call that said, well done, you've won the lotto. And they said to you on the phone, you're going to have 1 million Rand every year, starting in a year's time for 5 years. And you're going to say, whoop, whoop, thank you very much. I'm so happy. But you can't tell people that you've really won 5 million. Because you and I know that 1 million in a year's time plus 1 million in 2 years' time, etc., is not really the same as getting 5 million right now. So what we need to do when we're dealing with money in the future here is we've got to bring it back to the present using this little formula here that I'm doing. But since we don't really like to do maths, sometimes people will use a table. I'm just going to show you this once because we're never going to use tables after this. We're going to, in fact, just use Excel to do these sums. But you can see here, for example, if I'm 1 year away and the interest rate is 10%, and we're going to talk much more about what this interest rate actually is later, you can see in this little table here that I'm getting a factor, which we call a present value factor, of 0.909. So if I were to take this number over here and multiply it by 0.909, it would give me the present value of this number over here. And I could come along here and do the same for this one over here, and it's going to be equal to that times, now I'm 2 years down here, so it's going to be times 0.826. And the next one will be equal to year 3. And I'm just going down the table here, 0.751, and whoops, that didn't work. So that should have been times in here, and still got it wrong. it's got to be, sorry, that times 0.751. And if we were just to copy this to the right, and I just change these numbers over here because it's going to be 0.683 over here, 0.683. And in the last one, it's going to be 10%. It's going to be 621, 0.621, like that. Then you can see, if I were to, now that I've got these things into the present, and I shouldn't really put them like I've done here because this sort of implies that it's happening in year 5. It would be better for me actually to take this column over here and just put it over here, and I'm just going to actually transpose it by clicking values and transpose somewhere here. And in fact, this is what this money is really worth. Let me take this out now. And you can see that this money in year 0 is worth 90,000, and the next one 86, and so on over here. And if I were to add all of these things up, if I say give me the sum of all of these numbers that I've got in present value terms now, it's going to tell me that actually the answer is about 3.79 million. So that's the kind of thing we're going to do. But we're never going to use tables again. So I'm going to delete this, and I'm going to delete, well, maybe I'll just move this now so that you can actually see how it compares to what we're going to do. Normally in Excel, what we're looking for with these kind of calculations is something we refer to as the net present value, or NPV. I'm sure you've heard of that. And Excel's got a function which does this automatically for you. If you say equals NPV, in other words, give us the NPV, you can see it asks you, first of all, for the rate, the discount rate. And you're just going to say, use that number over there, put a comma, and it says, where are the values? And you would just highlight all of these, and you can go as far as you need to go. And if we press enter, we're hoping to get an answer pretty much like 3.791 million. And there it is, exactly to the cent. And you can actually see that we're a bit out with this data over here because we didn't have enough decimal places. If I delete that, you're going to see now that if I were to do this differently and I set this up as a bank account, just to show you, and I put into my bank account 3.79 million. So I'm going to come along here, and I'm going to do this the way a bank would do this. They would start with the opening balance, then they're going to say what interest did you get or did you pay, and what cash out or something like that, and maybe a closing balance. So the bank, let's say you took 3.791 million, this number over here, and you put it into your bank account. So at the end of year 0, you've got 3.7 whatever it is million sitting in your bank account, and at midnight you put it in, and the next morning you're going to see it's still there, nothing's really happened or changed. But at the end of year 1 you'd have earned some interest on this, wouldn't you? So if I say let's take this amount here and multiply this by 1 plus not even that, I just want to multiply it, in fact, by 10% just to get the actual interest, and I'm just locking that down. You can see we would have earned a little bit of interest on this. But we are now going to pretend that we created our own lotto prize, and we're going to draw from our bank account the 1 million. And let's just put that into the same format. Sorry, what am I doing? Here we are. So we're drawing R1 million out of our bank account, and if we add up what we've got here, if I say equals the sum of everything that we've got in here, you can see our bank account has gone down a little bit. But if we now carry this forward, and I'm just dragging this to the right, I'm just going to make all of these columns a little bit wider so that it all fits. So you can see I'm just getting that to the right, and I can just copy this formula to the right as well, because I now want the interest on this amount over here. You could do this in your head, of course. You're just going to knock off 10% here. So copy that to the right, and I draw out another R1 million, what's happened to my bank account now? You can see it's dipped a little bit more. And if I were to just take all of this and just copy this for the 5 years over here, don't worry too much about what I'm doing in Excel. What I'm really trying to show you here is that if you took the present value, 3.79 million, and you deposited in the bank and you earned interest on it and then drew out the million each year, it would exactly match the same set of cash flows that you got from the lotto. Put differently, getting $1 million every year for 5 years is exactly the same as getting a lump sum of 3.791 million in today's terms. So that is the principle of what we are really trying to do. Let's take a look at a quick example over here. Let's say someone came to you and said, if you invest in my project 50,000 Rand, at the end of the first year, you're going to get 40,000 out of the project, and then another 9, and then another 9 at the end of the second and third year, respectively. If you knew the interest rate was 10%, would this be a good investment? Now, you know that we can't just add up these numbers here. If you did, you can see here it would come to 58,000, but you can't just add up numbers because these are in different time frames. We would have to, again, discount these amounts back to the present, and we could use the tables, but far easier for us to, in fact, do a NPV calculation of this, and let me do it over here. So this would be, I'm going to call this the net present value of the benefit of this project. This is just going to be what we get out of it here. This is the net present value. Sorry, this should be an N, shouldn't it? Net present value. This would be the net present value of the investment because it's already in the present. We're in year naught here. So if I were to use that same function that I showed you just now and said equals NPV and said the rate is 10%, comma, and then picked up these cash flows here, it'll give me the NPV of the benefit of this project. So just putting this into the same sort of formatting here, you can see here that if I just underline this, I've got a present value from investing in this project here of, well, let's take the difference. It's that's what I get, and that's what I had to invest to get it. And you can see I've made some money. I've made 563 Rand and 49 cents. So this is, in financial terms, we would say this is a good project for us to invest in. We would have made money on this. Now, it's tempting to look at this and say, yeah, but we've actually only made 563 Rand and we had to invest 50,000 Rand, and so maybe it's not such a good project. Well, there's some logic to that argument, but actually it's not quite as simple as that. And the rule we use is if you get a positive net present value here, then you should accept the project. If it's minus, you don't. Now, I want to just back up a little bit here and show you the same sort of thing as it would have happened if we had put this into the bank like we did with our lotto example over here. So I'm just going to copy these things across here just to make it a little easier for me and just put that there. So our closing balance in our bank account is, let's change this. I want this to be minus 50,000. We've borrowed 50,000 Rand from the bank. I'm just reflecting the fact here that we had to get this money from somewhere to invest in the project. Now, at the beginning of the next year, this would have been the same. We would have had minus 50,000 in here, and we would have had to pay the bank this time 10% of this because we'd have interest due at the end of the year. So it would be that times this 10% over here, which I'm just locking down. So I'd owe the bank 50,000, but this time I would be getting back 40,000 Rand from my investment. And if I just underline this, I can now sum all of this up, and you can see that I've got, just making it all look the same with Rand signs and so on, you can see that my bank account is now sitting at minus 15,000. If I copy this to the right, and again, let me just make these columns a little wider so it all fits a little bit more. And I start off with 15,000. This is my closing balance. It becomes my opening balance. I would have to pay interest on that, and that would cost me 1,500. Then I would get in 9,000. I'm just pulling that down from the top. And if I were to add all of this up, you can see I'm still in the red. I still owe the bank 7,500, but yeah, carry that forward. I pay interest on it. I get the last 9,000, and my balancing figure is 750 Rand. Now, you ought to be saying, why is this different to this? Well, that's because this is in the present and this is in the future. If we were to take this 563 Rand and 49 cents and leave it in the bank, it would be equal to this next year times 1 plus this 10%. In other words, we're going to grow it by the interest rate. In fact, I should just lock that down because I want to copy that in a moment. So my bank account would have 619 Rand 83, just earning interest. And if it earned interest again and again, you notice that it's exactly the same amount. Exactly. Has to be. That's just the maths. Now, we never like to talk in terms of what it's going to be worth at the end, because in 3 years' time, inflation would have made this amount less. We wouldn't be able to buy it today what we can buy for 750 Rand. So we prefer to delete this and always work in the present. So coming back here, if I know I'm going to have 750 Rand in 3 years' time, I would want to bring that back to the present, and I can just do not a net present value this time, but very similar. In fact, I just want a present value of this amount right here in time naught. And I would say, I can use Excel for that. I can say equals the present value. Notice not the NPV this time, but just the PV. And it asks me some stuff. It says, what is the rate? I'm going to say the rate is 10%, and use that number up there, in other words. Then it's asking me N per. That's the number of periods away. So I'm just hard coding this as 3. It's 3 years away. It says, is there a payment every year? This function can accept payments every year, but there isn't in this case. I'm just trying to take this one amount of money back here. And then it says, what is the future value? Well, I know that. It's 750. And I'm going to close the brackets there. I don't need to put anything else into this function. Now, Excel doesn't exactly know what I'm trying to do. It thinks I want to know how much I must invest today in the bank so that I will get 750 out of it in 3 years' time. That's just the logic that Microsoft built into Excel, and it makes sense once you get used to it. But if I press enter now, I'm going to get a minus number telling me that I have to invest it. But you can see, although it's minus, it's actually exactly the same as that amount. And to fix the minus, I'm just going to put a minus here. In other words, multiplying it by a minus. And what I'm trying to show you here is that this in the present is exactly the same as that in 3 years' time, given that interest rates are 10% here. And we just prefer to work in the present because we know what 563 Rand will buy us today. So that's our starting point. Okay, so let's look at another example. I've set it up here, and let's assume that we want to buy a house. It's going to cost us 2 million Rand. We can get a bond, but the bond's only going to cover 90% of the cost of the house. And so we'll have to have a deposit of about 200,000 Rand. And of course, I should just write in here, don't forget you're going to need a little more than that, because in addition to all of that, you're going to have to include some legal fees, and legal fees, there'll be some transfer duty and so on. There's also going to be bond registration costs and a bunch of other things. I'm just mentioning those things as well to you. But the thing we're interested in is, well, what will the bond be? So it's going to be 2 million minus the 200,000 deposits. And so we need to then see what this is going to cost us per month. That's kind of what we're trying to do here. So to do that, we need to know a few things. We need to know the term of the bond. How long will this bond run for? And let's assume it's going to run for 20 years. Now you'll notice I'm putting the 20 on the side here because you and I know that although it's 20 years, we pay this bond off monthly. So we are always interested when we do these kind of calculations in the number of periods that we actually are going to be paying the money over. So that'll be equal to that times 12. So we'll have 240 months where we have to pay off this bond. The second thing we need to know is the rate. What interest rate are the bank going to charge us? And again, these rates are quoted in annual terms. And let's say you could get this for, let's say 10.5%, which is pretty much prime at the moment. Now, this rate that the bank quotes you, you'll notice I put it in this column as well because it's an annual rate. And it's actually a special kind of annual rate. The bank called this a nominal annual compounded monthly rate. That's because all interest rates are quoted in annual terms. That's where the nominal annual comes from. But you and the bank also know that you're going to be paying interest on this monthly. Now, because of that, and don't worry too much about this, I just want to show you this. Actually, your interest rate is going to be higher than 10.5% because you're not waiting until the end of the year before you pay 10.5% on what you borrowed. You're paying this number divided by 12 each month. So the bank's getting your money a little bit earlier and it's compounding in the bank itself. If we wanted to work out what we sometimes refer to as the effective rate, we would do it like this. We would say it's going to be equal to 1 plus this rate over here divided by 12 because that is the amount you're going to be paying each month. And then we would compound this to the power of, in other words, 12. And then I must just subtract the one I started with. And you're going to see that actually the rate that you're really paying, this is sometimes called the effective annual rate. Yeah. And it's actually a little bit more, 11.2% on this. And somewhere in your bond statement, you'll probably see that amount mentioned. But nobody's really going to pay it any more attention after that. I'm just going to delete that for now, not to confuse us. So the rate per month will be that amount divided by 12. And you'll be paying per month, just putting some decimals on here, about 0.88% per month. Now, what you really want to know is what is the payment that you're going to be making each month. Now, Excel can easily do this kind of stuff. And all you do is you would tell it equals, to tell it it's a formula, PMT. Tell me the payment, put in some brackets, and you'll see it asks you information. Now, everything here has to be in months. So the rate must be that amount, which is in months. The number of periods must be that amount in months, comma. Then it says, what is the present value of the bond? Well, that's the present value of the bond. And then you can see here that it wants to know the future value and the type of bond. The future value of the bond is going to be 0. That's what we're aiming for. But sometimes with things like cars, there's the residual. And very, very occasionally, you might have to pay interest at the beginning of the month instead of the end of the month. But usually those things don't apply. So I'm just putting it in like that, pressing enter. And you can see here, it's telling us that your payment is going to be about 17,000 Rand per month. If that's too small a house for you, you could easily just come up here and you could buy a bigger one. Make this 3 million and put that in, and you're going to see, well, now you can afford a decent house. It's going to cost you 27,000 per month. Now, just to prove this, and I don't need to do this, but let me show you. If you were to come down here and put this the month down here, and we're going to start with, say, month 0, and next month will be that plus 1, and I want to copy this down. We need to go 240 months, so I'm just oh, went a little bit too far, but somewhere here. I want to just delete all of those months here. I'm going to show you month by month how this would work out, because the banks will have this set up in their ledger. They're going to say, what's the opening balance of your bond? They're going to say, how much interest are we charging you? What payment did you make? And then they'll have like a closing balance, a bit like we were doing earlier. So our closing balance at the end of month one will be equal to, and I'm just reversing the signs here because we're going to owe this money, aren't we? Sorry, I'm just getting a bit lost here. We're going to owe 2.7 million. So I'm putting that there. That's our bond. At the beginning of the next day, it'll be equal to the closing balance the day we borrowed it. And at the end of the month now, the bank are going to charge us interest on that. So that times this interest rate per month. And I'm just locking that down. And so we would have to pay, we're paying, in fact, 26,000, but the interest is only a portion of that. So let's put our payment in here. And again, I'm just changing the signs here because I want to show that we owe the bank that. So I put a minus sign in there. And so our closing balance will be equal to the sum of what we started with minus the interest plus what we've paid. A bit like what we did just now. Now, once we've got all of this, sorry, I just need to lock that one down. We can just copy across here, and we can copy this all the way down, and you can see the thing to check here is, does it look like the bank is getting, the loan is getting a little bit less? You notice our payment is always the same, but the balance must change. Obviously, we want to pay the bank down. If I zoom to the end here, you can see after month 240, my balance that I owe the bank is exactly 0. So that's what we're trying to do. So your payment needs to be 26,956 or something like that. If you wanted to, in Excel, you can just highlight all of this. If you press F11, you should get a little chart, and you can see it's showing you that to begin with, your bond doesn't go down very fast, but as you get towards the end, it starts to ramp down fast because most of your payment now is going to pay the capital off. But people do crazy things here sometimes. Now, let's just look at a couple of things. Sometimes people say to you, well, if you add up all your payments that you've made over here, over whatever this was, 20 years, what does it come to? Well, we can do it, and it comes to 6.5 million or something, but that number is meaningless because we haven't taken into account time value. You and I know that the hardest payment you're going to make on this bond will be the very first one. By the time you get to 20 years down the track, that'll probably buy you a cappuccino. So you can't add those things, and even though they do show you these numbers on your bond somewhere, hit delete, it's meaningless. But another thing that is useful is to start thinking, well, if we were to pay an extra 2,000 every month, let's say we had spare money, well then this amount, if we were to now add this 2,000 to our payment, whoops, and you can see it's gone up to 28 something. And I want to copy the same amount. So I'm just going to say, let's assume we keep doing that every single month forever. If I click on the chart, you're going to see we've now repaid our bond much more quickly. And if we were to keep on paying, and if the bank gave us the same interest rate on deposits as they charge for loans, which they don't, you can see I'm trying to get the number here, we'd have about 1.6 million left in our bond account. So does it help to pay off your bond earlier by paying more? Of course it does. But you also have to ask yourself, well, maybe you could have done something else with this extra 2,000 you had. You could have, of course, bought a bigger house, if you believe in houses, or you could have taken this money and invested in the stock exchange, which might have done better than houses. So you have to kind of compare it to alternatives. So that's kind of just showing you this type of time value of money in practice. So just to wrap up, Excel's got several functions that we're going to use when we start looking at time value of money issues. This is one we saw, the present value, and we hardly ever use one which takes us into the future, but there it is. This is the one we use, payments, to work out what the value of a payment would be for a house and so on. And NPV is a very useful function here. And you saw us using that a little bit earlier. There's one more, which we occasionally use, called the internal rate of return. I'm sure you've heard of that. It sort of works backwards from the NPV and works out the rate if you know what the values are and what the investment was. So we'll come to that in due course. I hope you found this useful. And I suggest that it might be good just to practice a little bit, put in some examples, to have a go at Excel. And I hope you found this helpful.